I know this graph is a little bit different. I understand that. It's really the same idea, though. For the domain, you have to project it onto the x-axis, okay? Okay, so let's draw those lines. Although I guess really you don't, well, let me draw the lines. 0.5, right? So you can see it looks like we start at 0.5, that's in the domain. You have 1, that's also in the domain, right? Same thing here. Keep on going, right? The x-axis was, the graph is below the x-axis here. Here, the x-axis is below the graph now. Oh boy. Okay. Hopefully you can get the idea. Here we have, looks like 2 line segments. Okay. As you can see. Oh boy. Trying to draw some, don't want to draw too many, but I don't want to draw too little. Here we go. And finally, it looks like, so it looks like we're gonna get everything from 0.5 all the way to 6.5. So it looks like everything there, oh boy, it looks like everything there is in the domain from 0.5 to 6.5. Okay, that's good. I know that's kind of a messy drawing, but hopefully you get the idea. For the range though, right? How do we get, why is the range, why is the range from -1 to 2.5? Well, let's draw those horizontal lines. As you can see down here, -1 is definitely in the range, right? So if we keep on drawing those horizontal lines, right? So it looks like we're going to draw, the graph is always to the right of the y-axis, okay? Now, notice I could keep going to this part over here, but I don't have to because all we care about is the range. So I'm stopping once I hit the graph. Okay. Yeah, so once I get to the graph, I just stop. Once I get to the top here, the peak, so to say, boom, yep, there we go, now we're good. So it looks like we get -1 to 2.5. Again, I didn't go from here all the way to the other side like this. I mean, I could have, but all we care about is the range though. So that's really not going to tell us anything new, except that this point, was it 1.5, has two different inputs have an output of 1.5. Okay. So that's how we get the range for that. And that's it for chapter 2. So are there any questions about this? Okay, well, now we get to do chapter 3. So the first thing in chapter 3, once I get to it, is we're going to graph quadratic functions. Oh wait, no, not that. Let me, where am I? Oh, there they are. Okay, here we go. Here we go. Oh, there we go. Okay, good. Wasn't closing at first, but here we go. Here we go. So we're going to graph now quadratic functions. 3.1 is actually pretty short, so it's not that bad. It's actually kind of a fun section. Okay, so remember, what is a quadratic function? We have seen it before. A quadratic function is a function of this form, as you can see. That's a function of this form. Okay? You know, basically it's a function f of x, or you can call it f of x, but basically it's a function defined by a polynomial of degree 2. Okay? That's just what it is by definition. Let me just get rid of that. There we go. Okay, I just wanted to fix that. So, but the polynomial, it's basically a function that's defined by a polynomial of degree 2. Right? So if I call the function f, right, I can use g if I wanted to. but you have ax squared plus bx plus c, where a, b, and c, these are numbers. A, though, cannot be 0. I mean, if a were 0, we'd be back with linear functions, lines, but we did that already. Remember also that we saw this already, that the graph of a quadratic function is called a parabola. That's what the graph is called. It's a parabola. Okay? I mean, it turns out it's actually going to look like the graph of y equals x squared, which we've seen already. It might be, how do I say this? It might be turned upside down. It might be stretched or compressed horizontally, but it's going to look something like that. What's nice about these functions is their domains are all the same. Their domains, namely, they're all the set of all real numbers. That's what their domain is. The range, however, will vary. The range will depend on A, B, and C, as we'll see shortly. Okay. Just to refresh our memory, what do these graphs look like? Well, for instance, here's a graph of y equals x squared plus 1. As you can see, the domain is all real numbers. The range here, using what we just did, is going to go from 1 all the way up to infinity. I didn't draw the arrows here, but the range does go to infinity, or as in this case, to minus infinity. Okay? So that's what the range does. So again, this is y equals x squared plus 1. Okay? I mean, again, just like I said before, you can imagine drawing those horizontal lines. I didn't draw it here, but you can hopefully see that they would go through everything above, including 1. Whereas over here, the graph is pointing down, right? So the range is going to go now from 1 down to minus infinity. But in both cases, the domain is the same. So the graph is going to look something like this. It might be flipped, it might be shifted to the right or left, or even vertically, so stretched or compressed horizontally. But it's going to be some variation of that, which is nice. Okay. Yes?
So just a quick question. I know like in the prior classes we went over how to find the domain, like, with the equation, but did we do the same for range as well? Like,
No, not for range. No, not from equations.
okay, so it's just the domain out of the equation.
I'm sorry?
So we just need to know how to find the domain.
Yes.
Okay, thank you.
From equations, yeah. From the range, maybe visually, but what's nice is in this section, at least, you can actually get the range like more, how do I say this? Well, you can get it without using the graph. You'll see what I mean, though. So.
Okay, thank you.
You're welcome. Good question. Are there any other questions at all? Anyone or? Okay. Well, notice here also that the a is 1. Remember, a is the coefficient of x squared, right? If it's not written, it's understood to be 1. Whereas here it's -1. When a is 1, the graph is pointing up. As you can see here, the graph is pointing up. Here it's pointing down. Well, that's actually no accident, because in general, if your a is positive, I'm going to try and draw this as well, the graph is going to open upward. So here's what happens when a is positive. Again, I want to draw the arrows in. Okay. I mean, on an exam, if you don't have the arrows drawn, that's okay. I'm not going to get that strict. And if a is negative, so this is what happens when your a, oh boy, let me see if I can draw the a, is positive, right? When a, however, is negative, that's going to open downward like this, okay? That's going to open downward. Okay, so that's good. So, it's just something that's good to know. Also, if you look at these if you look at these graphs, okay, you can see that there is some point where the graph changes direction and goes the other way, right? I mean, in other words, you can imagine, walking along the graph, like a trail, and then here you reach the lowest point and you change direction. Same thing over here, right? You're walking along the graph, you reach the top, right? And then you walk down, and then you start walking down. So here we reach a point where we change directions. Here it's the top of a hill, so to say, and here it's the bottom. Okay? That point where the graph changes direction or the graph turns around, that's called the vertex of the parabola. We call it the vertex of the parabola. So again, that's where the graph changes direction. The graph turns around.